This is one of the latest images captured by the James Webb Telescope in 2026. You might think this is just a beautiful nebula. Wrong. Scientists say we may have already witnessed in advance the fate of our sun 5 billion years from now. Zooming out, you'll see its true, full structure. It is called the Helix Nebula. Some also call it the Eye of God. It looks like a massive, glowing ring, floating in deep space. It is only about 650 light-years away from us, but its internal details had never been seen before until January 2026, when Webb observed it in infrared. It revealed a dense interior, filled with comet-like, not structures. There could be around 7,000 of these structures across the nebula. The size of a single head can reach up to twice the size of our entire solar system. Astronomers say, when you look into this eye, you are actually looking at a preview of the sun's fate 5 billion years in the future. If even a star like the sun will eventually become like this, then what about the more violent and ancient objects in the universe? What extreme forms could they evolve into? So in today's episode, using images released over the past few months, a batch of newly released space imagery will travel from the death of stars to the edge of the universe. If we say the previous image was a remnant left behind at the end of a star's life, then this one is what it looks like when stars and planets are just beginning to form. At their most chaotic stage, it has a very interesting name, called the Dracula's Chivito. From the name, it may sound playful, but it is actually an extremely violent stellar nursery. This is a protoplanetary disk, the stage before planets are fully formed. Why does it have this name? One of the researchers is a fan of vampires, who thought the filaments rising from the top of the nebula looked like Dracula's fangs. Another researcher is from Uruguay. He thought the dark dust lane in the center looked like a traditional chivito steak, a sandwich, but don't let the name fool you. This sandwich spans about 64 trillion kilometers in diameter, about 40 times the size of our solar system. The material within it is enough to form an entire giant planetary system. This is essentially what it looked like when our solar system was first forming 4.5 billion years ago. A chaotic, dusty, yet hopeful beginning. If the previous image showed the chaos before stars and planets were born, then the pillars of creation are something humanity has observed for decades, but never fully understood. In 1995, the Hubble Space Telescope captured it, and the entire world was stunned. But within the Eagle Nebula, 6,500 light-years away, those three towering pillars have always hidden secrets. What Hubble saw was only the surface, because it observed invisible light, revealing only dense, opaque Helix clouds. But this time, the James Webb Space Telescope used infrared to see through that wall. After piercing through the dust, you find that inside those one-star columns are densely packed with newly forming stars. It's like looking at a solid wall before, and suddenly switching to an X-ray view and discovering it's filled with beating hearts. The tallest pillar stretches about 4 light-years long, equivalent to the distance from our sun to Proxima Centauri. Webb reveals that this pillar is being slowly eroded by nearby massive stars. In about 100,000 years, this iconic structure will completely dissipate. What we are seeing now is actually its final, most beautiful moment. If the pillars of creation represent beauty, then this image at first glance might send a chill down your spine. This is not a medical scan, nor an artist's imagination. It is a real deep space image captured in February 2026 by the James Webb Space Telescope. It is known as PMR-1, nicknamed the Exposed Skull Nebula. It lies about 5,000 light-years away from Earth. The shape is extremely unusual, with a transparent outer shell resembling a skull. The internal gas clouds are divided into 2 hemispheres, with a distinct split in the middle, strikingly similar to the structure of a human brain. Most intriguingly, Webb used 2 different instruments. The near-infrared camera image resembles a ghostly transparent skull, while the mid-infrared instrument view reveals glowing dust within, as if the brain itself were lighting up. This is also a snapshot of a dying star in its evolutionary phase. Its ultimate fate depends on the mass of its central star, whether it will end as a supernova, or evolve into a white dwarf, or collapse into a black hole. We do not yet have a definitive answer, and precisely because its fate is uncertain, this skull-like appearance feels even more eerie. And behind the next image lies one of the most ambitious projects in human history. Last year, on a mountaintop in Chile, the Vera C. Rubin Observatory began its survey mission. It is equipped with one of the most powerful astronomical digital cameras ever built, with a resolution of 3.2 billion pixels. This means, to view every pixel in full detail, you would need about 400 4K screens combined. Its first image targeted the Trifid Nebula and the Lagoon Nebula. This is not just a single image. It is the first frame of the longest cosmic time-lapse ever attempted. Over the next decade, it will repeatedly scan the entire sky to capture objects that move, brighten, and suddenly erupt across the cosmos. The previous images were either strangely beautiful or bizarre beyond imagination. Now let's look at something truly extreme. This image that looks like golden mountains actually shows one of the most extreme regions. In the Milky Way is the Pismis 24 star cluster. It is about 5,500 light-years away from Earth, hidden within the Lobster Nebula. How extreme is this environment? Those glowing mountains are actually gas clouds being eroded. The surface temperatures of stars here can reach up to 8 times that of the Sun. One prominent object is known as Pismis 24-1. It was once believed to be one of the most massive single stars in the universe. However, Webb observations revealed, it turns out, it is actually composed of at least 2 extremely massive stars, gravitationally bound in a closed system. This environment is essentially a cosmic furnace. If you think images within the Milky Way are already spectacular, then you are underestimating the vastness of the universe. Now let's shift our focus beyond the Milky Way to Messier 82, the Cigar Galaxy, 12 million light-years away. It indeed resembles a glowing cigar tilted in the dark, but Webb's observations reveal that this cigar is on fire. From the core of the galactic disk, massive red-orange outflows of gas are erupting both upward and downward, forming a structure like a burning cosmic hourglass. These are galactic winds composed of extremely hot material. Why is it so violent? Because it is a starburst galaxy. Its star formation rate is about 10 times that of the Milky Way. How did this intense activity begin? Scientists suggest that its massive neighbor, Messier 81, gravitationally interacted with it millions of years ago, forcing large amounts of gas into its core. This galactic encounter from millions of years ago is still driving ongoing bursts of activity today. You should know, the universe is approximately 13.8 billion years old. This explosion occurred when the universe was only about 5% of its current age. That was during the epoch of reionization, when the first generation of stars and galaxies began to illuminate the cosmic darkness. The James Webb Space Telescope not only detected this supernova event, but also identified its host galaxy. Although in the image, it appears as only a few red pixels, it carries information that has traveled for over 13 billion years. This represents some of the earliest observable evidence from the edge of cosmic time. But this is not the end, because the next object, MOMZ14, truly pushes human observation to the furthest limits of cosmic time. It is currently the most distant confirmed galaxy, MOMZ14. The designation informally suggests something like a mirage or miracle. The light we observe from it was emitted approximately 280 million years after the Big Bang, due to the continuous expansion of the universe. Its current comoving distance is estimated at about 33.8 billion light-years. In observational images, it appears as a faint pale yellow smudge. Yet these few pixels have significantly challenged previous cosmological models. Earlier models suggested the early universe was relatively sparse, with few well-developed galaxies. But MOMZ14 indicates otherwise. Galaxies had already evolved to a more mature state and exhibited unexpectedly high luminosity. This implies that in its infancy, the universe was far more active than previously assumed. It is even possible that during that time, many processes occurred that remain beyond our current understanding, beyond the vast distances we cannot traverse. The universe also presents profound observational puzzles. For example, this image of the galaxy cluster PLCK G165. Among hundreds of galaxies, 3 arc-shaped points of light appear. One might assume these are 3 simultaneous supernovae, but they are actually multiple images of the same supernova event. Astronomers have nicknamed it HOPE because the cluster's mass is extremely large. Its gravitational field acts as a powerful gravitational lens, bending and magnifying the light from a distant supernova behind it. Because the light travels along different paths, some longer, some shorter, their arrival times on Earth differ. This allows us to observe the same supernova at 3 different stages of its explosion. It is analogous to observing on a single screen someone's birth, their adulthood, and old age simultaneously. Now let us bring our focus back, because near the center of the Milky Way, there's one of the most puzzling regions for astronomers, the Sagittarius B2 molecular cloud. What makes it unusual is that a set of key observations remain inconsistent. This cloud contains only about 10% of the gas in the central region, yet it has produced roughly 50% of the stars there. This is comparable to a factory using only 10% of the raw materials, but producing 50% of the total output. How does it achieve this? The James Webb Space Telescope probed deep into this cloud and found numerous opaque dark regions. These are actually high-density dense cores. In these compact regions, a new generation of massive stars is forming. This region is one of the future power sources of the Milky Way and one of its most enigmatic stellar nurseries. Finally, let's expand our perspective further and look directly toward the center of the Milky Way. This image was captured by a radio telescope in South Africa, showing a portrait of the galactic center. The bright white central region is Sagittarius A*, which is the supermassive black hole at the center of our galaxy. In this panoramic view spanning about 1,000 light years, numerous bubble-like supernova remnants are visible. The key detail is this. The James Webb Space Telescope in this region captured dozens of extremely thin, needle-like luminous filaments within this highly turbulent central region. They maintain an almost perfectly parallel and linear structure. This is caused by extreme magnetic fields generated by the black hole's influence, shaping the surrounding interstellar medium. This is the center of our cosmic home. It is more magnetically active and violent than you might imagine, and also more fascinating. After viewing this collection of images, you may notice something intriguing. The more powerful our telescopes become, the more unfamiliar the universe appears. From the future remnants of the sun to galaxies already mature in the early universe, these images do not provide definitive answers, but reveal even greater unknowns behind them. With every layer we uncover, there is often an even deeper layer of mystery beyond. What makes the universe truly astonishing is not merely its grandeur, but that it is vast beyond comprehension. Yet we cannot resist looking up again and again. Thanks for watching. Add Astra to the stars. See you in the next journey through the universe.